Now, we will continue with the problems related to two shapes. So take the case of a square pyramid. Square pyramid is being cut by a section plane inclined to HP, perpendicular to VP. So you'll be drawing the cutting plane, mark the cutting points 1, 2, 3, and 4. Project it down, get the top view. 1 and 2 will be cutting OC and OD, O dash C dash and O dash D dash. 3, 4 is cutting O dash A dash and O dash B dash. So 3, 4. After getting the top view of the cutting points, join 1, 2, 3, 4. You can see that the true shape is a trapeze. If you cut a square pyramid, true shape is a trapeze. Okay, so here project in order to get the true shape, project 3 and 4, 1 and 2, take the distance of 3 and 4 from the XY line, get it, and you can see that the true shape is a trapezium. Now, I need the height of the trapezium as say 40 millimeter or 50 millimeter. What I will do? You know that if you cut the front view of the solid, the width of the cutting plane will be equal to the height of the or width of the true shape. Here you can see that the height of the trapezium is exactly equal to the width of the cutting plane in the front view. Okay. So if I need this height is equal to 50 millimeter, identify 2 points such that the distance between these 2 points becomes 50 millimeter. So you will be identifying by trial and error method, identify 2 points such that the distance between these 2 points becomes 50 millimeter. Then project it down, get the inclination of the cutting plane, find the true shape. Okay, this is a normal way, but if this height is given, we will be solving the question like this. But trapezium, you know that it is having the height as well as these two sides are also having some measurement. So the next type of question is, provided this distance is given, say 30 millimeter and 40 millimeter, that is, this width of the trapezium is given, then how will you solve that question? If this height is given, this width is given, you can use this method, cut the front view such that this width becomes this distance. Okay, so how will you solve if these two sides measurements are given? So my question is like this, given 20 millimeter and 40 millimeter sides, this distance is not given, provided suppose if these two measurements are given, then this is not having much significance. Okay, so how will you solve this question? If this distance is given, it will be easier. Take this height, this width as this measurement, you can draw the cutting plane. But I told you in the previous video, whatever width coming here will be exactly equal to these two measurements. So if you want this distance as 20 millimeter, identify 2 points such that this distance becomes 20 millimeter. So I will take 20 millimeter. I can mark this point as 1 and 2. Okay, and you identify or draw a parallel line and such that this distance becomes 40. Then top view you can see that you will be getting a trapezium. And how will you locate the cutting plane? So this is being cut OD and OC. So you project it up, project this point up. So it will meet O dash C dash and O dash B dash. So that point is 1 and 2. And you project this point up, you'll be getting 3 and 4. Okay. Now I can draw the cutting plane this way. Now normal practice is in order to get the true shape, draw a line parallel to this, project this point, 3 and 4. Now get the true shape point 3, take the distance of 3 from the xy line and 4 from the xy line. Take the distance of 3 from the xy line, mark it here, you get 3 and 4. This is the distance, cut it here, 4 you will get. Now what is the distance between 3 and 4? This will be exactly equal to whatever distance you have marked here, because this distance is 40, then this will be also equal to 40 millimeter. Okay, that is why I have drawn here the 40 mm line, because in the true shape I need this measurement as 40 millimeter. Now I will be projecting this point also, 1 and 2, take the distance of 1 from the xy line, mark it here. The distance of 2 from the xy line, mark it here. Now you can see that the distance between 1 and 2, this vertical distance is 20, so this distance will be also equal to 20. Now we got a trapezium such that the measurement is 20 and 40. So this is why I told you, whatever distance coming in the plan will be equal to the height, or this width will be equal to whatever distance coming in the plan, and whatever distance coming here will be exactly equal to the width of the true shape. The height of the true shape will get it from the plan, and the width will get it from the width of the cutting plane in the front view. And one more problem here, that is you cut a cube such that the true shape is a regular hexagon. So I think it would be better by heart that problem. In order to get, if you cut a cube, in order to get a regular hexagon, draw the square such that it is equally inclined. Then only you will get the true shape as a regular hexagon. So cube, you should draw the square base equally inclined, and you should either by heart, or you should remember that the cutting plane should pass through the top end and bottom end, and it should be through the midpoint of this side and midpoint of this side. Okay, you draw the cutting plane such that cutting plane is passing through the midpoint of this side and this side, or if you are taking this side, it should pass through the midpoint of this side. So you can draw the cutting plane such that it is passing through the midpoint. So you will be getting, so this point is 1 and 2, 3, 4 and 5, 6. Put it down, you will be getting 1, 2, here 5, 6, and this point will be 3 and 4. So you will be getting hexagon. The true shape, you can see that true shape will be a hexagon, and this width will be equal to the width of the hexagon, the diameter of the hexagon, or the diameter of the circle. Okay, thank you.